Welcome to From Gear to Code, Cybersecurity in Automotive Engineering. Enjoy this special webinar session.
Hey, hi.
Sir, shall we start, sir?
Yeah, sure, Mr. Yeah.
Okay, thank you. So good evening to one and all present here. On behalf of the management, principal, and academic leadership team, the Department of Mechanical Engineering, Chettinad College of Engineering and Technology, I extend a warm and a heartfelt welcome to our distinguished speaker, Dr. Vishal Saraswat, and all the participants joined us for today's webinar on From Gear to Code, Cybersecurity in Automotive Engineering. As the automotive industry rapidly evolves towards the connected, intelligent, and the software-defined vehicles, cybersecurity has become a crucial component in ensuring safety, reliability, and innovation. So this webinar provides an excellent opportunity to gain insights into this emerging and highly relevant field. We are privileged to have Dr. Vishal Saraswat, Head Research and Innovation, Cybersecurity Practices, Bosch Global Software Technologies, Bengaluru, with us today. His extensive experience and expertise will undoubtedly enrich our understanding of automotive cybersecurity and its future prospects. I sincerely thank all the participants for taking the time to join this session and being a part of this learning experience. I am confident that today's webinar will be both informative and inspiring. Once again, I warmly welcome everyone and wish you a fruitful and engaging session of today's technical webinar. Thank you all. And to formally introduce our distinguished expert speaker, I now invite Dr. V. Hari Prasad, Head of the Department Mechanical Engineering, to present the speaker's profile and welcome him on this session. Over to you, sir.
Thank you, Dr. Om Prakash. It's given me immense pleasure to welcome you all for this webinar. Let me introduce the chief guest of the day, Dr. Vishal Saraswat, Head Bosch Cybersecurity University, is a leader in the field of applied and practical cryptography and drives cybersecurity research and innovation and competence development and crypto services at Bosch Global Services Technology. His expertise includes anonymity and privacy in communication protocols, confidential computing, searchable encryption, lightweight cryptography, post-quantum crypto, and blockchain security. Dr. Saraswat is a distinguished expert on the Board of Academics of the Department of Mathematics, MNIT, Allahabad, India. He is an executive committee member of the Cryptology Research Council of India and has served on the editorial boards of several security and cryptography journals. He earned his PhD in cryptography from the University of Minnesota, USA, and has served at several prestigious institutions, including University of Minnesota, IIT Jammu, IIT Hyderabad, ISI Kolkata, University of Hyderabad, and AIMSCS Hyderabad. Dr. Saraswat has led multiple funded projects, supervised several PhD, MTech, and MS students, filed multiple patents, published extensively in reputed international journals and conferences, and has co authored the book Introduction to Cryptography that makes cryptography more accessible for researchers. He has consulted and trained for various intelligence agencies, defense organizations, policymakers, academic institutions, and industry organizations, and actively engages in raising cybersecurity awareness among the non specialists through popular media contributions. In addition to his cybersecurity research, Dr. Saraswat is passionate about planetary health and environmental preservation and is leading research on the ecological impact of emerging technologies and superheading the green cybersecurity initiatives at BGSW. With this, I handed over the session to Dr. Vishal Saraswat, sir.
Hey, so First question, are you still able to see my screen? Because on my screen, it looks like I'm not sharing any screen.
Sir, your screen is shared.
Screen shared. Okay. What I'll also do is I'll shut off the camera to save some bandwidth. Okay.
Sure,
And
sir.
hopefully, and if there is a network issue, Om Prakash, please do call me and we'll figure it out. Okay. So
Absolutely.
I'm
Do
stopping the
the favor.
camera for the time being. All right. Great. Okay. So now that you can see the screen, let's uh, welcome to this talk on cybersecurity and automotive engineering. You already know me now due to the beautiful introduction by Professor Harprasad. So, yeah, at Bosch, I run this program called Bosch Cybersecurity University. The mandate is doing research and innovation, do competence development. So we do a lot of teaching, training, etc. Within Bosch and outside Bosch. So we are running, for example, a postgraduate diploma program in automotive cybersecurity at BITS Pilani. So we do that. And I do, like, I'm a distinguished expert on the board of academics of MNID Allahabad and so on. So I'm used to be mainly in academia before I joined Bosch around 7 years ago. So yeah, in this talk, we'll talk about some automotive cybersecurity. What are the advances that are happening in the automotive domain? We look at some of the threats that are out there. And we look at some real world cybersecurity breaches, some challenges, why it's not easy, right? And yeah, we'll look at some finally future trends, what's happening in this field throughout the industry. So even if, like, around 20 years ago, if you thought of cars, the cars were mostly mechanical devices, right? Even when you put in the engine, etc., in the car, the whole thing was mostly mechanical. So if you had to turn left and you were turning your steering left, basically it will depend on how much force you applied, and that force that you physically apply will help you vehicle turn left, etc. And then slowly electronics started coming into the picture, initially for maybe listening to radio, maybe getting some infotainment, etc. And then we started having power brakes, power steering, power windows, when instead of like uh, turning the gear around, you just press a button and the job is done. Okay? So when you just turn a tiny bit left of your steering, it's not a mechanical work that is happening, but a signal goes to the wheels and they turn according to how much you have turned the wheel upstairs, right? Which is in your hand. So instead of being a mechanical machine, it started becoming an electronic machine. Okay? And so much is happening in the automotive world nowadays. Like the cars are getting electrified. You have hybrid cars, you have e-motors, you have power electronics, plugins, and so on, right? And that means this electrification itself is a huge topic in the automotive industry nowadays. Okay? And then automated mobility, right? You are talking about cars which are completely driverless. In fact, in certain geographies, they are testing out completely driverless cars, right? Uh, and then, of course, even in India, you might have seen, for example, Mahindra XUV 700, right? If you are driving on highways or freeways, it can do a lot of job on its own. It can figure out whether you are within the lane, you're going out of the lane, and so on. And even at some places, you can even leave the steering completely, and the car will steer on its own. Hmm? And the connectivity that in the car has coming right now, within the car you can connect with your devices. The car is connected to the backend cloud. The cloud is or even entertainment clouds or other kind of clouds, right? And then maybe depending on what kind of car automated mobility or electrified mobility. They are some of the topics happening in the car world. Okay. So we'll come back to that in a bit again towards the end. So let's start. Right. So nowadays, even an average car may have anywhere between 25 to 100 electronic control units. And if you're talking about average high-end car, it could have anywhere between 300 to 500 electronic control units. Right? And these ECUs, they are connected to various sensors and actuators. So sensor would be, let's say, a video camera that perceives that, okay, your car may crash, or some other kind of sensor. And depending on what you sense, you may actually do something, right? The car is going to crash, maybe apply brakes and so on, right? And the car is connected within like various components of the car. They are connected using various protocols, wired protocols, nowadays even wireless protocols and so on. And within the car, you have so many different devices, so many different components. Each of them have various safety requirements, which of them have various functional requirements, various efficiency requirements. Let's say you apply brake and you don't want the signal to go to the actual brake, that taking a minute or so, right? You apply the brake and you want the car to immediately stop, right? If you are steering and you want to turn left and the car takes a minute to turn left, that's not gonna do the job. You want the car to turn immediately. So depending on your requirements, some things have to be really fast, immediate. On the other hand, if you are talking about, let's say, infotainment topics, like you are listening to radio or you are watching some video on the car, there, well, the speed maybe does not matter so much. Of course, you'd want to have a smooth audiovisual experience, but also something that is coming here is the amount of data that is passing through. Okay? So a video file could be very large and you want those video frames to be coming pretty efficiently. The window system, right? You press the button on the window. If it takes a millisecond or two, it's okay. Yeah, you don't care so much of the speed about it. And generally, the data that is there when you are raising a window, that is going to be not so much, right? You turn on the AC and the AC air starts flowing through the vent. Of course, you want the car to become cool as soon as possible. Need not be high, the required bandwidth may not be high, the throughput may not be required, may not be very high. On the other hand, sometimes you have huge amount of data, so you need enough bandwidth, you need enough memory, and you need very high throughput. And that car then itself becomes so complicated, maintaining different kind of networks, different kind of physical cables or interfaces to maintain these requirements, to satisfy these requirements. And it's not just ECUs within the car, it's not connectivity just within the car. The car is connected now, right, outside. It's connected to so many different things. The car is connected. The simplest is, of course, the key fob, right? You just press a button on the fob and the car doors open. You can even possibly turn on the AC from the fob and so on, right? The car may be connected to radio towers, skulls. And then there might be different other connectivity, like mobile connectivity. The car may be connected to your home's Wi-Fi. You may need to charge your car, so that means connectivity to charging stations. You may be able to insert your USB drives or some other kind of ports might be there in the car, which can be physically accessible. And so many different kind of connectivity interfaces. And the more the interfaces, that means the more amount of interfaces available to attackers. They can use these different channels to mount attacks on your vehicles. And then, of course, nowadays we are talking of intelligent transport systems. Your car should be able to talk to various infrastructures. Your, like on the road, this traffic signaling is happening in an intelligent manner. The cars are talking to various towers, various kind of antennas. They are informing them that, hey, I'm passing by or something. That is happening. Various sensors are observing the cars, like variable speed limit enforcement, etc. That is happening nowadays. Instead of having maintaining a speed limit which is constant, let's say 100 kilometers per hour on a road, the speed limit changes depending on how many cars are on the road at that moment, how things are happening. So instead of having a 100 kilometers per hour, they may change the speed to 80 kilometers per hour, and so on, right? Similarly, the traffic signals that are there, that may be more dynamic based on the traffic done in an automated way. That means the cameras, they have to sense the vehicles. They have to figure out how many vehicles are going. Okay? And then many times even the cars may want to send some signals to other cars on the road, especially when we talk about automated cars. This becomes very important. So car-to-car communication happening. Okay? So you are going at a very sharp curve. If such communication could be done, which we generally nowadays do by honking, right, or by flicking our lights, but that is inefficient. Sound pollution, light pollution, whatnot, right? So if this communication can be done so that cars can communicate to other cars and let them know that, hey, I'm turning around, without creating so much of sound or electric sound or light pollution, right? So those are happening, and a lot of emergency management services, especially during the most of the cars will have some sort of a weather channels, and they'll get weather info, etc. All this means that the car is communicating with the backend infrastructure, or the infrastructure on the road. They are communicating with the car, but that also means attackers can use this communication to attack the car, or maybe steal certain information about this vehicle, and so on. And if they could they could disrupt this communication, they can cause accidents, etc. So so much of different things coming into, right? And then, of course, we spoke about automation. So many different companies now are investing into automated cars. Tesla has their own car. GM for various levels, right? Automation will be achieved. That means we are at level 5, where the car is completely driving itself without any assistance from humans in the car, right? Or basically anywhere. Okay? That would be like level 5. That's what it's called. But level 4 would be where you have high automation, where the car will drive itself, but it's good to have a human in the car who can control it if needed, right? Level 3 is where actually it comes with a disclaimer that, hey, the driver is responsible. Even though the AI is driving the car is doing everything on its own. But when there are issues, when there are problems, the driver must intervene. Okay? Or somebody, sometimes as it's happening in US, somebody at the back end who's controlling the car, and they do intervene. So somebody has to intervene, basically. Okay? So yeah, of course, you have this level 0, and there is no automation. Level 1, where some assistance to the driver, like beeping when some obstruction is there or something. Sometimes you have partial automation, where the car will help you park in the right place, but or perform one or two things, but most of the work has to be done by the human, and so on. So that's the advancement that is happening in the automotive world, and that means that threats, they are increasing. Threats to the safety of humans, the people in the car, people outside the car, and with so many data flowing here and there, that means the privacy of the data, the secrecy of the data, that becomes a concern. If I can track where your car is going, I can basically track what are you doing, where are you going, right? So your privacy is lost. uh, there are attacks on the system integrity, the various if somebody comes and manipulates the software updates that are coming to the car, or the data that is coming to the car, or data going out of the car, and all those, right? Or even physically connecting to the car and tampering the system, all those issues are there. Okay? And that means trusting the advancements, that becomes difficult. A car is becoming automated, but can I really trust it? Okay? And we'll talk about some of those issues, trust issues. They are real. Okay? So when new features come, when new technologies come, it becomes very difficult adopting them into the automotive industry. Okay? And of course, due to this various concerns and various political reasons and other reasons, we have tons and tons of regulatory requirements, regulatory control, and they need to be satisfied. And that those become another pain point. Okay, and we'll talk about some of these. So yeah, and when somebody steals your or somebody hacks into your phone, somebody hacks into your computer, somebody hacks into your bank account, somebody listens to your communication, what is the maximum loss that you'll have? You lose some data, you lose some money, you lose some privacy. Okay? Somebody hacks your car, you lose your life. So lots damages are like really, really bad. So if there's a security breach, you may lose control of your car. And that could have serious implications, right? The people can die. And of course, if you guys have watched movies like Fast and Furious, you have seen that there's a chance that there's a malicious takeover of the car that happens. And if that is happening, then somebody else is controlling the car, and that is dangerous. And I'll show a tiny video in the next few minutes. So of course, the communication systems, they can be disrupted. Your data can be manipulated. There could be, of course, services. Maybe your data is not available. Maybe your music is not available. And then, of course, privacy violations. So that can happen. While I'm
excuse me, sir. So the screen is not visible.
And there's something in the chat. Let's see what's written in the chat. Okay, there are just basically hellos and highs. Okay, let me move forward.
Sir, the screen is not visible.
The screen is not visible. Let me reshare.
Oh, sure, sir.
Yes, I won't know if the screen is not visible to you, so just let me know when it's not happening, okay? Is this visible now?
Now it's okay, sir.
No, it's okay. Okay. So yeah, so when there are security incidents, you have a lot of damages possible. Even your privacy point of view, your personal data can get exposed. Your activities, they can be tracked and surveilled. your identity itself can be stolen, and somebody else may start using your identity to start living a new life, or maybe even do some malicious transactions, and you may get in trouble. The data could be even manipulated, and it could be shared in an unauthorized manner. So your data could be sold on the dark web, etc., and that could create problems for you. So many threats, so many, like even somebody does not even need to access your vehicle directly. They can just access these vehicles remotely. They can hack into your vehicles in a remotely and try to create trouble for you. There could be man in the middle attack, so somebody in the sitting in between the car and let's say back end and sending some sort of just even observing your data, which would violating your privacy, or even manipulate that data. There could be denial of service attacks. So let's say you are not able to get your certain services, maybe your GPS is not available, maybe your music is not available, or sometimes even somebody could just brick your car. So that is like your car will be hacked and you can't do anything with your car, you can't drive or anything. That is possible. Your sensors can be manipulated by remotely, so that when you think you are applying the brake or they are not getting applied, or when you think you are going at a speed of 50 kilometers, but you are actually going at a speed of, let's say, 100 kilometers. So all those issues can be there. And once you have got those, then there could be malwares or ransomware that could be injected in your car. So basically, that's called jackware and so on. So many different, and if nothing else, somebody who's able to control your car, they can just convert it to use it as a part of a botnet. Use various network ports of the car to do some malicious activity somewhere else. So lots of threats are there, and let's move to some breaches that have already happened. Right? So, when tons and tons of breaches are happening for a while now. Of course, initially it started with attacking just trying to steal the car. Those were the initial attacks on car, or hacks of the car, where attackers just would steal a car. But later it became even more serious, like attacker could remotely open the doors of cars, and then somebody could come and access your car, get in the car. That started happening, and then even more fancy stuff happened within the same year, where attackers could remotely access a car and then control its functions. And I'll show you such a video in a couple of minutes. So yeah, means tons and tons of attacks have been already seen in the world. And the point is, these attacks that we see, they are not just theoretical, not just by researchers, they are real attacks. So, of course, why not put somebody from cybersecurity, hire a cybersecurity expert and implement it on the cars? Not so better security in the cars, and they were talking about it. They wanted to implement it, and they were even making big claims about implementing it. But even though they were speaking it for more than 10 years, by 2010, almost every car that was there, they're getting stolen using what we call relay attacks. And I'll show you an example of relay attack very soon, and I'll give you more details about it in the next few slides. So while all the companies, yeah.
Sir, again, the screen is not visible. I think there is a internet break.
This is the, to me it's showing that I'm sharing a screen, but let me reshare.
But we couldn't able to see it.
Uh,
If you could reshare it, then it will be okay.
okay.
Yes, sir. Please.
Yeah. Yeah. So, in fact, it so happened that somewhere around 2010s, etc., this guy called Elon Musk, who was the founder of PayPal and got a lot of fame as a guy who could secure financial transactions using PayPal and had a very. He comes and he says, I'm going to make a computer on wheels. My car will be like a computer and I'll secure it. If computers can be secured, cars are easy to secure. And he makes very big claims and he releases the car called Tesla. And immediately, as soon as it's comes to the market, uh, came to the ground reality that hey, securing cars is a different story altogether. Securing financial transactions is different, and securing cars is different. So you cannot just. It's not easy. That's at least you got to know. So of course, uh, uh, what Musk was able to do is the way he had designed his car. Even though there were vulnerabilities in the car, what Tesla did was they sent software updates to these cars and they fixed the vulnerability pretty quickly. Okay? Almost within a week, almost all the car Teslas that were in the market, that were in the field, they were all patched with the software update. Okay, and that's the first time when automotive industry really took security seriously. They took a good design seriously, the good software design seriously, and that's around the time when automotive industry really started hiring software developers and software architects to make their uh, cars much more efficient and much more secure. So you can see this video over this network. So look at these guys, the way they are dressed in this video, right? They come with complete this clothing so that they cannot be identified easily. Okay? And and this is a real video. This was released by the police to so these guys have come. They are looking at the car, and now one of them goes closest to the door, the garage door. The idea is the car keys will be hanging somewhere inside, right? Generally, we don't hang our car keys very far from the entry door. Right? So they go and they try to capture the signal of the key. Okay? They communicate with the key close to the which is inside the building, and from that key they collect the signal and send that signal to the car. So the car thinks the owner is pressing the fob button. Okay? Now they open the car door, but after getting into the car door, the colleague realized that, oh, he's not able to start the car. So that's why the colleague had to come back to do a next relay of the signal, which is for starting the car. Okay. Now they efficiently took the car and this is stolen. It's a Mercedes that was stolen. Okay. And it has not been recovered. And if you go to YouTube and search for vehicle theft videos, you'll find such videos a lot. And this one is one of the official videos shared by the West Midlands Police. But there are many such more incidents. Okay. So if you don't secure your car properly, of course, the easy thing is your car will get stolen. But that's just not it. There is so many other issues. Okay? And this is where like another incident here, basically a few researchers, they showed that they could hack a car and they could control the car. Okay? Again, this video that I'll show, it's also available on YouTube and you can see it in your free time. But let me quickly show you this video. Okay? So, guys, you are able to listen to the audio?
Sir, the video is not visible, and audio also we couldn't hear it, sir.
Your screen is not shared again, right?
Yes, sir. Screen is
I
not
think
shared
this
again.
platform has some issue where the screen keeps getting unshared due to whatever the reason, I think. Because to me, it shows that it is shared. Okay? So, I don't know. If this keeps happening, I think you guys should change your platform. Okay?
Maybe look into that, sir.
Yeah. Okay, I've unshared and let me share it again. So is this screen shared?
Yes, sir. It's correct. Sure.
And now let me start the video and let me know if the video is audio is available or not. Is the audio available?
No, sir. Audio is not available.
Okay, in that case, I'll keep talking.
Okay.
So basically, here, these two guys you are seeing on the video, they developed a piece of software, and so these two guys, and this is a demo they are doing with a journalist. This journalist who's driving a car, and they were remotely able to connect to the car and they were able to completely control the car. Okay, so the guy who's driving the car, he could not control his steering. Whatever he was doing with the steering, the car did not listen to the steering. Instead, these two guys, they were turning the car left or right. They were failing the brake. So this guy, when he applies brakes, the car won't stop. On the other hand, if the guy wants to speed or wants to slow down, they could remotely apply brakes or even kill the engine on a highway. Okay, so think of it: you are going at 100 kilometers per hour, and your car suddenly stops. The car behind you will come and hit you, and you'll have an accident. Okay? Or maybe the car in front of you stops, and you hit the car. Again, you are in problem. So all these things that are happening in this car, they are being done remotely. Like, for example, this windshield wipers they are running, they were not started by the actual driver. These guys are doing it from far. Okay, so it, so yeah, this kind of attack, and if you this more video to go on, but basically these guys demonstrated that they can connect to any car and attack, right? So the guy was not able to apply the brake and nothing. Okay? So let's move to the next slide. And this means that if attackers can start controlling cars, they can use cars as a weapon, right? And that has already happened, like of course not by remotely controlling a car, but so in so many terrorist attacks, cars are used as weapons, right? Just some terrorist or some psycho, they'll just get into a car and just start hitting people, right? We have seen cars being used as bombs. They'll pack the car with a lot of explosives and then go and hit into something. Okay? And of course, here, when somebody is sitting in a car and with a bomb and doing it, they need a lot of motivation, right? uh, 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 just a sec. Means you have to worry about, like, the guy has to be willing to die themselves. Okay? So that is uh, uh, but if you can control the car remotely, okay? Hmm. So that is a that can be a mm, like very dangerous situation then, right? Remotely I control any car and I use that as a weapon. Then terrorists will have a field day everywhere, right? And again, this theoretical scenario was shown in a movie. Okay? So there's a movie called Fast and Furious, I think 5 or 6, where this happens. Where again, and this is somehow this platform does not share the audio, so that is a. Uh, you guys are still seeing the screen, right? Yeah. Okay. Screen is shared at least. Okay.
Yes, sir.
So again, in this scenario, what happens is, and this is a movie sequence. Again, possibly you can search for this Fast and Furious car hijacking scene. In this case, a terrorist is shown uh, to fly over the city and control the various cars that are going in the city. Even if the target car they want to control, that might be secure, but even if I'm not able to hack that car, I can hack other cars and create traffic jam, even use those cars to to physically attack these cars. So, and that's what this scene is. So, I'll let the students enjoy this scene for a couple of minutes and then I'll take it up again. So, so uh, I have a question. The students, can they speak back? Are they allowed?
Hello, sir.
Yeah. Are the students allowed to use the mics?
Yes, sir, they can.
Okay. Okay. Yeah. Yeah. So good. So that I'm checking so that if they have any questions, anything to comment, etc., they can keep doing that. Okay. So yeah. My video froze for a second. Wait. Okay. So over here, if you are seeing the cars, the car drivers, they are not able to control their car. Instead, this car is being remotely controlled. The person in the car, even if they are doing this. So this is just actually the previous video which I showed those two hackers. They were actually consultants on this movie, and in real life they had shown how to hack one car. But the idea is, this is a concept where if you have advanced, possibly you don't even need so many people to control these cars. You can use agents to control these cars and do whatever you want to do. And yeah, and the attackers, the hackers, they are causing kind of a chaos in the city, panic in the city. Okay? And they are remotely controlling these cars to almost attack somebody else who is supposedly secure, and they think that they cannot be attacked. Okay. So yeah, I'll skip this video. I'll share the links with you guys. I can do that, but let's skip this. But yeah, so that means when we are talking about security of cars, that has meaning. It's like your life is on stake and you have to worry. And of course, they were very serious hacks, but there are different kind of hacks happening nowadays. Okay, your car is completely logged and there's hacked, and it's the ransomware one kind of blocks your car. You can't move your car, you can't do anything with your car unless, let's say, you pay a certain ransom. Okay? And those kind of attacks are happening, and that means again, this is a small thing. If the person does not want to kill you, but you don't want to give, they just want some money from you. Okay? But that's also a nuisance, right? So yeah, all kinds of hacks are there. So again, simple trick: go ahead, hire some cybersecurity guys, and you are done. Not so easy. Securing a computer is very easy. Securing a network is easy. Securing a university is easy. Securing a car, not so easy. Okay? Because generally cars have a lifetime of 30 years, and when they are operating over 30 years, and there are so many different variants of the cars coming. Okay, and you have to keep the security, maintain the security for these cars, and you have to maintain the same level of security, not just now, 30 years from now. How do you predict? How do you ensure, like, how do you know how the world will be 30 years from now? Some of you who were alive and understood, remember 30 years ago, so in 1996, mobile phones were not so popular in the country. Okay? If you go another 5 years back, you could not even think of mobile phones in the country. So much different the world was. Okay? And nowadays, mobile phones are so much powerful. Right? So when you are working with cars, you have to worry about a long life. Generally, with computers, networks, their lifetime is like around 5 years. That is a short time period. And the thing is, generally, these computers and these networks, they are within your control. Okay? For a car maker, once you sell the car is outside. Okay? And not within the control of the car maker. On the other hand, when you buy let's say, Apple iPhone, most of the software is still in the control of Apple. You are always connected to the Apple ecosystem, and they can fix it. Not so much with the cars, right? And the thing is, when we talk about cars, there's so much of supply chain. That means basically many different suppliers, they are supplying components of a car. Okay? And this is not just like one supplier supplying directly to the car. Okay? You have tier 1 suppliers, and then you have tier 2 suppliers where your supplier got some supplies from somebody else, and then you have tier 3 suppliers where that guy is getting from somewhere else, and so on. So this various levels of suppliers creates a complex web, and keeping track of where is your software coming, where is your components coming, that becomes really, really tricky. And ensuring your quality of your product, that becomes very, very tricky. And how do you maintain that? How do you ensure the security of this components, security of the various softwares, etc., that you are getting from various different cars, right? So that becomes very tricky. And even after the car is produced and it leaves the factory, there are so many different stakeholders who are involved, right? During the making of the car, the designers, then during the production, then you have to worry about the repair service. So you have various service centers, insurance for the car, so you have to work with the insurance companies, various air pollution check and other kind of checks, with the regulation checks, you have to work with them. So that means so many different kind of stakeholders are coming into the picture, so many different people are coming into the picture, and each of those humans, they could be compromised. Each of those services might be compromised. That means if anybody is compromised, your car gets compromised, your product gets compromised, right? So how do you maintain the security via when the car is changing hands among so many people, right? So the supply chain management, the stakeholder management, that becomes. And then is what is our expectations from the users when the car gets needs some service. The general expectation from the user is they just go to the local person, gets it fixed, right? They don't always go to the dealership, they don't always go to authorized service centers, or that means nowadays kind of they are forced, but that's such a inconvenience. That means replacing components, etc., that is done by third party providers. How do you ensure the security of those? And not just security, how do you integrate those in your car? They may not fulfill your security requirements. And the amount of software that is in the car, that is humongous. Average cars nowadays, they are having 100 million lines of codes. Okay? And the more and more sophisticated cars are becoming, you could have 200 to 300 million lines of code. That is even more than what is the lines of code that is there in the Windows operating system or the Apple operating system or Facebook or even the operating system planes, etc. Right? So when you have so much lines of code, and frankly, generally not the best developers work in the automotive industry. Okay? They are not the highest paid guys, right? So that means, as I said earlier, you are getting this software from so many different service providers. It is coming through a really very complex network of supply chain, right? And the smaller companies, how do they figure out, right? How do you ensure that the quality of code is good? And the more the code, more the chances of bugs coming into picture. So that's another something to be taken care of. And then so many standards, so many regulations, so many legal requirements when it comes to cars. So various governments, various markets, they want the cars to be safe. They want the cars to be secure. But that means it's a cost on the companies. They do they really implement security, or do they just do some sort of check mark? They have some sort of an Excel or something, I don't know, and they just try to fulfill those checks and get the certifications. Okay? And that means this doing a cost trade-off. The cars are becoming more expensive if we want to have all these regulations to be respected. Okay? That is another problem. So many problems, what to do, and who should do the security. So many people coming into picture, right? So when we look at cars, and there's so much, you have a car as a system and you have to worry about the vehicle system security, and then the security of the vehicle, okay, within the components, etc. And then you have those various electronic control units, and you have to secure each of those ECUs. And then the software that you are using within the ecosystem, you have to secure the software. Okay? And then the various chips that you're using, okay, microcontrollers, etc., that you're using, they need to be secured. So that has a cost. That is a pain point. And the more the use cases, the more the features, the more complex your security is becoming. Maruti or Mahindra, it's their job to maintain the security throughout the life cycle. And here, of course, because they are looking at this vehicle as a whole, they have to ensure that when they get various components from various suppliers, that should be interoperable. It shouldn't, like, I have certain security mechanisms, they don't work with the OEM's security mechanisms. And then you have various suppliers. The ECUs are being supplied by somebody. The software is being supplied by somebody. And then while the OEM is overall responsible, the supplier who's supplying your ECU, the supplier who's supplying the software or anything, they become responsible for the security of this individual items. Okay? And this is generally implemented using various contracts and so on. Okay? And of course, finally, the chip makers, they have to be responsible for the security is in a contractual manner. That now becomes another complication. Okay? And that has to be done various legal departments, lawyers make the money. Okay? So when we say what are the issues at the vehicle level or the vehicle system, the system layer, so many issues to take care of, right? There are so many interfaces to the outside world in a vehicle, the diagnostic port, the Wi-Fi, Bluetooth, USB, and so on. Okay? And for each of these interfaces, you have various standard-based securities, but you have to implement those in the right way, and those become problem, or they need to be addressed. Let's not call them they become a problem, but these problems need to be addressed. Okay? And so many functionalities that are being done that have to be taken care of. So the car may be connected to certain cloud, certain other networks, that those have to be fixed. Okay? And then when we look at the suppliers issues, the ECUs and so on, okay, then we have to secure the car internal network. Okay? So it could be your CAN bus, Ethernet, or LIN, or CAN FD, or whatever. You have to secure the network. You have to secure these ECUs themselves. So that means you have to have various kind of mechanisms. Okay? So you have to look at boot security of each of these ECUs. So what happens when the car starts at that time? If somebody made some changes when the car was offline, when you had parked your car in the garage, so you have to ensure the boot security. Each of these ECUs, maybe we're operating on various OS like Linux or QNX or whatever. At that time, you have to ensure the security of those operating systems. And yeah, when a lot of your security credentials, passwords, cryptographic keys, they would be there. They would come into the time during production, etc. Those have to be secured. Lots of drilling is required. A lot of component integration that is received from vendors, that is required. So vendor may be using some sort of HSMs, TPMs. They have to integrate with your systems. That is required. And all these issues, they are an interface for an attack. And similarly, at the lowest level, at the chip level, there are issues that need to be addressed. So yeah, lots and lots of topics to be taken care of. And so again, let me ask if there are any questions at this point. If not, let's move forward. So let's look at some future trends. The hacking techniques, they are becoming much and much sophisticated. So we have to prepare for those. The hackers are becoming much, much smarter. And generally, the defenders are slower. Right? Criminals are faster. Police is slower. That's a of course, to the security of the cars. Right? AI and machine learning vulnerabilities, they are coming up, right? So hopefully some of you or all of you should know about AI Claude Mythos, right? Nowadays, AI-assisted attacks, AI finding vulnerabilities, AI mounting attacks, sometimes AI itself mounting attacks, they creating issues. All those things are happening, and this is just new world now. Right? We are not used to so fast-paced attacks. Okay? So that is changing the whole world. Cars need to be more and more connected. That means a lot of infrastructure needs to come into picture, and that means the security of the infrastructure needs to be there. Security of these various kinds of connection needs to be there. Okay? Uh, of course, the supply chain security needs to be ensured. And supply chain security is such a big problem. Sometimes we don't even know where did our components are coming from. Okay? And people are injecting malware during the supply, during the production. Okay? Some of you might have heard about the Lebanon pager bombs. Right? That was basically a supply chain issue. At some point, some hardware, some firmware was injected when in during the supply chain, okay, and which was not supposed to be there. And then lots and lots of regulations and ethical challenges coming. Okay, so these are some of the topics that are being addressed. This is some of the research areas, and this is what the companies are investing into. At this stage, of course, so many things to be done. I'll actually skip all of those and discussions. So let me turn on my video for you guys. Hopefully the video is visible. And yeah. Hello.
Yes, sir.
Yeah, so yeah, please, any questions, guys?
I think I've asked in the chat box also to post the questions, but still we have not yet received any questions.
Eh, yeah, means I could talk a lot, but if you don't have questions, any AI or tools used for vehicle cybersecurity? A question from Mr. Hariharan. Yes, nowadays when it comes to cybersecurity, tons and tons of various kind of AI tools are used to protect. Of course, attackers are using to attack. Now, AI tools, when you use the term AI tools, there are so many different ways AI is used, right? You could be simply using AI tools for your pen testing topic, for vulnerability scanning topic. Okay? Uh, your SOC management, your incident management, intrusion detection topic. So, yeah, for many different things, AI is used. If you have any specific thing, maybe you can speak. Any other questions? Yes, I understand this is a Friday evening. All of you are ready for the weekend. Something
There is a question in the chat box.
in the chat box. Okay. Which type of ADAS system can be hacked easily? Well, the one which is not designed properly, has not done a thorough pen testing, generic. Um, okay, new question. What's the latest prevention method to stop vehicle hacking now? Well, what we do at Bosch, or in general, that's recommended for everybody, is integrate security right from the beginning. Whenever any component that is being designed, okay, figure out, is security relevant for this component, okay, and do thorough what we call threat modeling, that what kind of attacks could be there, what could be kind of exploits could be there, and figure out all possible kind of threats, okay, and then figure out what are the possible damages from those threats, and do a thorough risk analysis, that each of these threats, they can uh, they'll have certain amount of damage if this actually happens, if somebody uh, attacks your car in a certain manner, okay, if they bypass your, let's say, Bluetooth security, or if they bypass your Wi-Fi security or something, what kind of damage they can do, okay? And based on this, how much damage you can have, you try to figure out the risk, like, okay, if this incident happens, I'll lose $1 million, but then times uh, year. Okay, so if it happens, I'll lose on an average $100,000, and it happens 10 times a year. That means I'll lose on 10 times 100, so it's $1 million per year. Okay? So that's your risk. Okay, and all right. So if can I implement some cybersecurity that will reduce this risk? So let's say you implement cybersecurity, and that costs you $200,000, but brings down the risk to $500,000. That means in a way you have saved $300,000, right? You spent 200,000, now your potential risk is only 500,000, right? So you do this risk analysis, and accordingly you invest those things, okay? And always do a full quality testing by doing a lot of testing, security testing, pen testing, fuzz testing, various kind of all the VNV that you do, but security aware VNV you end up doing. Okay? So yeah, and then have in place a thorough vulnerability patch management, have in place SOCs, the security operations centers, have incident response plans in place, so that if some incident happens, immediately you can react to it and take care of it. So yeah, means these are some of the basic things that are done. Okay, what advice would I give to aspiring engineers who want to work in automotive security? Well, if you have some background in the automotive world, that's a good thing. And generally, what I've seen is working in cybersecurity means you need to have a mindset of uh, thinking out of the box, trying to break rules. Okay, you need to have a mindset that there are people out there who will break rules. So you have to figure out how their mindset works so that you can defend it. Right? So there are criminals out there, how to protect against them. That means you have to think like those criminals. You have to predict what the criminals might do. Okay? So in general, uh, you have to think like that, and of course develop your capability according to uh, uh, your passion. If you don't like the job that you're doing, you're not going to be able to do a good job, right? So what do you like? You like to design things, you like to go into the mathematics part of things, you want to go into the theoretical algorithm part of things, protocol part of things. uh, so there is so much to do, and you're very analytic, so you want to do some sort of risk analysis. Figure that out for yourself, okay? And then develop your skills for that. In any job, you need to have this, right? You must love the job. your job should pay you, so you have to look at that. If I love singing, but I don't do a good job of it, that's not going to work. Okay, I love singing, I do a good job of singing, but nobody is willing to listen to my voice, not going to work, right? So you have to see what you love, what will pay you, and what are others willing to do you, and are you good at it, right? I love to sing, but I have a very bad voice, not going to work, right? So you have to do that trade-off and figure it out for yourself. Question: how do you secure radar and lidar systems? This is a whole different topic. This is something that I must excuse myself, and there are mechanisms out there, but I really don't want to go into this now. I must disappoint you in answering this question. Okay? But it's a very generic question. It's it's not a one-line answer or something, right? But basically, again, there are mechanisms to do this. Dear sir, please tell cybersecurity threats in modern vehicles. Hey, were you attending this class? I've been talking about so many threats. Okay? I'm sorry again. I have spoken about so many threats throughout this last 1 hour. Okay? What is Canvas and why is it important? Okay, yes. Canvas, basically, this control area network. This is a network within the car which connects various ECUs and manages. It's just a network. Okay? The usual enterprise network or normal computer networks that are out there. So that's called the Canvas. Okay? And importance because this is the one that is connecting all the core, or if I don't, let me not use the word all, but it's connecting a lot of the ECUs, the various actuators, various sensors, and that's where a lot of communication is happening within the vehicle. So when you are applying a brake and the brake signal goes to the actual brake pad, okay, that is happening over the canvas. Okay? So that's why it becomes important. Okay. So nowadays a lot of modern vehicles, modern OEMs, they are moving to Ethernet and they are moving to or CAN FD, but CAN FD will be just a next version of CAN. You can think of it like that. So it's just a network mechanism. Okay. Cybersecurity challenges in vehicle infrastructure, EV vehicle infrastructure. One new thing will get added basically. Okay. When you are talking about EVs, the charging infrastructure that is there, that new security requirements will come from there. When the EVs get connected to the charging points, again their security will come into the picture. And the batteries themselves, their own management systems, how the battery is being managed, that security will come into the picture. How is the battery communicating with the rest of the vehicle? That will come into the picture. So it will. So you'll have to focus on those and security info, right? So whether the brake pads or other sensors and actuators. So yeah, the role of AI and ML in automotive cybersecurity. Well, like in any cybersecurity, AI ML, it's the technology for AI ML that is progressing really fast. That means AI assisted attacks, they are becoming fast, and in scale they are becoming many, and so thwarting is them becomes much more difficult. AI can find out vulnerabilities very quickly in any product, so that means your response times have reduced. Somebody figures out a vulnerability and then exploits it to create a full kill chain that could be done nowadays within a few hours, and that means you have very little time to recover once an attack has started. So that comes into picture. So like in any other cybersecurity, AI and ML for defense has become imperative. You have to use, but it's also dangerous. You cannot give decision-making powers to AI and ML. Let's say you apply brakes, but AI thinks for some reason that, oops, this brake has been applied by an attacker, and they don't apply the brake, that means you die. Right? So the risk of completely automating is much, much higher in case of automotive domain then in a, let's say, server of a bank, some fraud is happening, block a transaction? Not much. Are autonomous vehicles safe from cyber attacks? No, they have actually much more risk, right? There is no driver there. That means the amount of risk that is there, that's much more. If the AI that is controlling the car, they take a wrong decision, if you can poison the data, if you can create AI things that it's somehow you create a filter so that a red signal looks green to the car, boom, there is an accident, right? So if you could send some signals to the car that, oops, there is no other vehicle in front of you, and it just goes, okay, accident. So autonomous vehicles have, again, a much bigger attack surface for the attacker. The attackers have a lot of options to create trouble for autonomous vehicles. So that requires humongous amount of security. Okay? So much more care in implementing the security is required. How is AI used in automotive security? Again, that part is again not meant for a quick answer, so I'm not going to address that. Okay? There's a generic question, and the answer will be very generic, and it's so I'm not going to address that. Okay? But I think I've spoken about the topic, that the importance of AI and where AI is used. That I have already spoken a lot. So let me please take that from this session. How part is the tricky part, and not for a quick session. That has to be whole new session. Okay, we can set up another 1.5 hours and talk about that part. Okay, so any other questions, guys? Yes, just a sec, guys. I'll open the door. Till then, if you have more questions, keep writing.
And so one more question is there, sir.
I just wanted to get your meeting. I'll come back later. Just nothing want to check, like, because of the issue that happened in front. Yes, I made outside.
Yeah, sorry about that. So, you are saying something, Om Prakash? Any new upcoming
There are questions in the chat box,
technologies
sir.
in the cybersecurity and automotive engineering?
Sir, we were not able to hear you for last 2 minutes. Like 30, 40 seconds, we not able to hear you.
Yeah, basically, I think I spoke about some new upcoming technologies like electrification. I spoke about ADAS or autonomous technologies. So a lot of technologies are coming up. Again, how can I use the machine learning effectively on the context of automotive industries? I spoke about some basic generic use cases already, so I think this question I'll skip. Major difference between traditional vehicle security and automotive cybersecurity. I think maybe autonomous vehicles, if you're talking, I already addressed that. Otherwise, this question has traditional vehicles. If you'll go back all the way back to the mechanical world, then there was no cyber involved, there was no connectivity involved. So that security was very different. At that time, the focus was on safety, not on security part, cybersecurity part of it. Cybersecurity comes into picture with connected vehicles. Okay? And then how many companies invest in the cybersecurity? Okay, this is almost all the companies must. Ideally, they should be investing, but this is a Google question. Some secure update mechanisms. Again, secure update is a full topic. Generally, you have to have authentication in place. You have to have integrity checks in place. You have to have even some sort of encryption in place to maintain the confidentiality, etc. So there are various ways of doing this. There are various ways of implementing this. Yeah. No, I am not going to do this. Now, this is a really, if you are not paying attention to the session, no, I'm not going to do this. I've spoken a lot. Okay, so give a recap of the technologies discussed in this meeting of the session. No, I'm not going to do that. Okay. Yeah, I think that's the last question, I think. If the video is being recorded, you can just go through the video and see it. Okay. Or just pay attention.
If there is no question, sir, shall we wind up, sir?
Yep.
Participants, any more questions? Shall we wind up the sessions? I think there is one more last question, sir.
Again, our automobile, the manufacturing is doing enough to address cybersecurity risks. Again, this is a debatable issue. This is not a technology issue. Okay? So I don't think this is the right forum for this question. Okay? Depends. Various companies, they are investing a lot, and cybersecurity itself is a cat and mouse game. Okay? Whatever kind of security technologies are discovered, the attackers will find ways to break it, and it becomes a cat and mouse game. Okay? And then sometimes, as a company, they have to decide what is the cost. Okay, the cost of security. If I implement if I put 100 locks on my door, opening it and getting out of the door will be impossible or very difficult for a daily basis thing, right? So you have to do a trade-off. That's what when I was talking about risk analysis. How many locks to put on the door? What kind of locks to put on the door? Okay? And if I put 100 locks, that they have a cost, functional cost and actual cost, right? So those analysis have to. So our company is doing means there are different companies with different philosophies. They have different things. Right? So some are doing, some are doing less, some are doing more, and frankly, it's not enough ever, because attackers will find many different mechanisms. Okay? So there are regulations which most of the major manufacturers, they have to comply, and they try to comply. Okay? So yeah, I think we can now. It's 7:28. So if no questions, we can stop now. Yeah.
Yes, sir. Actually, at the outset, I have to thank you.
Yep.
Okay. We'll wind up the session, sir. So as we come to the end of this enlightened webinar, I would like to express my sincere gratitude to our esteemed speaker, Dr. Vishal Saraswat, for sharing his valuable insights in the cybersecurity in automotive engineering. So actually, your presentation has provided us with a deeper understanding of growing importance in the cybersecurity in the modern vehicle and the challenges, opportunity, and moreover, a lot of things. So in this regard, I would like to thank you for your time and valuable support to our students and for the participants outside Chettinad. I also thank the management principal and the academic leadership team for facilitating this kind of technical webinar to the engineering community. So we hope that today's session has inspired our students to explore the emerging technologies in and the career opportunities in automotive cybersecurity. So thank you all the participants. Wishing you everyone a wonderful day ahead. And a special thanks to the team mechanical engineering who has taken up this time for being with us. Thank you, one and all. Thank you, sir.
Thank you. Thank you. Have a good
Thank you.
evening. Bye.
Participants, I'll be posting the feedback link in the chat box. Kindly do fill it. So the feedback link is in the chat box. Please
Okay,
do fill it.
I'll leave
It will be a great benefit for us to come back with more kind of technical webinars, such things.